Hello and welcome to my screencast in the course TDDD27. My name is Alvin Granat and I'm here to show you my MinStack application that uses Angular as a front-end framework and a Node backend with Express and mongoDB as the database. I'm also utilizing Firebase for authentication and also some storage, but I'll show more of that later. So this application is based on a startup at Linköpings Universitet where they have created a game for high school students to solve problems that are math related to their current courses in school. And then the teachers are supposed to be able to log in on an admin page or a dashboard to see how their students are performing. So if we view a simple ER diagram, an abstract overview is that we have users who are either students, teachers, or admins, whereas student can create classrooms and student can attend classrooms. And then we have the admin being able to create problems where the students are able to finish problems or complete problems, and the teacher is then supposed to be able to see how the student is performing at different problem areas. So that's the simplification of this, the structure I've made, that the problems have a particular area and then the teacher can see how many problems of a particular area a student has finished. So let's dive into it. The application, we start off by creating a teacher because that's how you get going. So we start to creating one called Erik Andersson and he is teacher. And then one thing to note here is that we have validation in the form using reactive forms where you can only continue if you have a valid form. So as last name is required, so you have to add one in to be able to continue in the form. So we have phone number, so I'm going to put mine in. And one thing to note here is we are forcing valid formatting for a phone number to be able to continue using regex expressions. So we have a phone number of the teacher, and then lastly we have an email address where we also check if the email address is correctly formatted in the same way using regex pattern validation. So yeah, we have an email address and we also have validation for showing that they're not the same email and a password. You have to have the same password twice to be able to create an account, as we can see here. So let's create a teacher account called for Erik Andersson. So we log in with Erik. And now we see that the navigation at the top has changed. Now we can enter a classroom page. When we click here, we can see that Erik has no classroom as of right now. So let's create one. Let's create 8C in Linköpings skolan, and we create a classroom. We navigate using the arrow navigation at the top here, and we can see, oh, the name is quite long, but oh, I put the wrong order. So yeah, now we have created a classroom called 8A at Linköpings skolan. And we can enter this classroom to see that we have a class at what school, and then the class has a code. And this is the teacher is supposed to be able to type this code on the whiteboard, and the students are then able to join this classroom when creating their account. We can also navigate to adding a student from the class page of a particular class. So let's click here. So now we're creating a student account. Let's call it Sara Jonsson. And now we can see that she has to enter a class code to be able to create an account. And this is validated using asynchronous validation in reactive forms in Angular to force a classroom to be present to be able to create an account. So if the classroom is not present in the database, the student is not able to create an account. Nice. So let's create a student account and let's log out Erik to log in with the new student account. So let's log in with the student account. So now Sara is logged in and the navigation has changed once again. Now she can enter the problem demo. Entering here takes a bit to load. We can see different problems being solved. So I'm just going to enter some correct answers to these. There are 3 types of problems. We have a problem in context, or well, I'm not having to mention the exact types, but we see that they have different colors here to make it simpler for the user, which is me, to see which problem is of which type. So let's just finish some problems. Okay, so now Sarah has finished some problems and a teacher wants to be able to witness how her student is performing. So let's log out of this account and log in at Erik Andersson again to see how Sarah is performing. So let's log in with Erik, go back to classrooms. And we have some sort of bug here, but let's ignore that. We go to 8A and now we can see that Sarah is here and she has and she is present in the classroom. So let's click on Sarah. And we can see Sarah's email address, if it's verified or not. We can see which class she belongs to, what school, and then we can see that she has indeed finished some problems. And here, this is a way to visualize how she's performing via a radar graph. So there are 3 types of problems, and she has finished 3 questions in problem in context and skill problem, but she has only finished 1 tricky question. So maybe this teacher can see that Sarah has some issues with some critical thinking or cleverness. I don't know. So maybe this is something she can use to get a good grip of how Sarah is doing in the game. So that's the basic idea of the visualization and for a teacher to be able to track the progress of her students. So if she adds more students, she will be able to see them here in the page. I mean, Erik is able to see how his students are performing here in the page. You also have a page for a specific profile, but this has not been implemented more than just with seeing the JSON object and then some random component. Nothing in particular to see there. But we also have admin users, as I mentioned, and if you have an admin user, you should probably guard the routes the admin enters, since they're probably very sensitive. So we're just going to check that out. If you want to enter admin page, I can't do that because only admin can access that page. Similarly, you can't enter classroom page if you're not a teacher, and you can't enter problem demo if you're not a student. But yeah, let's log in at admin and see how the admin page looks. So admins, as I mentioned, are supposed to be able to create problems. And here we can see the different kinds of problems that have been created already, listed in a fine way, where we can see all the questions and their correct answers. And the teacher can then also filter out particular types of questions, if they want, using a pipe here. And then we can also edit the answers to some questions if we want to. So for example here, 15 plus 3 equals question mark 18. Maybe that question is too easy, so we want to add a little bit of bigger number, and then we want to edit it. We can do that, and yeah, it gets updated. You can also delete a question and create questions. So we create a question, how many days are there in a week? Answer is 7. We create this problem. We go back to the problem list. We can see how many days are there in a week. And then we can either edit this question and then we can also delete it. Are you sure you want to delete this problem? Yes, I am. Problem deleted. And lastly, the admin can also witness and see how all the accounts present on the application in a nice table. And then we can see the names, emails, account type, ID in the database, and ID from Firebase. And then the teacher, the admin can also perform some actions on this page. So let's say we have a user want to delete here. Magnus Johnson has not been performing well, or for some reason we want to delete this account, we can do that. We press delete account. Are you sure we want to delete this account? Yes, I am. Then the account gets deleted and the list gets refreshed. Maybe I have more Magnus Johnson accounts. Yes, I did. I have 2 Magnus Johnson. We delete them both. But yeah, that's the basic functionality of the web page. Then if we look at the account page, we have 2 things to note here. One thing is that this route is guarded via sending the authentication token to the API, and then it verifying that this is indeed a logged in user, but also verifying that this user logged in is also an admin. So let's check how that works. So for every HTTP call I make, I've added an interceptor. So if we go to HTTP in core, we have HTTP service, which has all the classic posts. Well, the names are a bit changed, but we have post, we have patched, we have get, we have delete, and then we have added an interceptor for this, for all the HTTP calls, where this is not very easy to jump in instantly, but as it says here, if the user is logged in, if we actually have an auth user logged in at Firebase, so we have Firebase out service over here, keeping track, we have the out service over here, keeping track of the current user, out user. If there is a logged in user, we then intercept the HTTP call and add add the authorization token into the request's header, and it's formatted as the usually are. You add authorization header with bearer space and then the token fetched from Firebase in this particular example. So Firebase has their own token, which I then verify on HTTP calls. So if we go over to the so if I make an HTTP call, it will then get intercepted. The authorization token will be added if the user is logged in, and that authorization token will then be checked in the API to see if this is indeed a logged in person, and if this person is logged in, it will then, if need be, check if this user is an admin. So if we go to user routes in this case, we wanted to list all the users to view them here at the admin page. I have added first to check is this user authorized, and if this user is authorized, I also check if the current authorized user is an admin. So is authorized, we will skip for now and just check is admin. So is admin extracts the token, the header, the token from the header, and then it verifies this token using the Firebase SDK in the backend or in the API. So it verifies the token, and then when it has verified it, it then decodes the token, and I check if this user, filtered by its Firebase ID, which can then be extracted by the decoded token, if the user in the database has the role of admin, I can continue into the next part of the request, which is then, if you check back at the route user.list, and user.list simply lists all the users. So list is just finding all the users of a specific query, no query present at this point, so it then lists every single user and returns it. So in summary, the user, if you want to list all the users, first you have to be logged in, and if you're logged in, you need to be an admin, then you can access the listing of users. But this is one more thing to note here, that this is indeed present in mongoDB instead of Firebase. So we have 2 databases. One, we use Firestore to keep track of the problems, and then we use mongoDB to store all the users and also the different kind of information revolving the users. So mongoDB is more has more juice to it in a way, where it keeps track of user, as mentioned before, but also if the user is a teacher, it has specific information for the teacher, phone number in this case. And then if it's a student, it keeps track of specific information for the student, for example, the class code that the student have to create an account. And then finally the class, keeping track of the specific class and also having a specific code. One thing to note with the class, which is interesting, since we want to have a code for the class that the teacher is able to write on the board and teacher then re-entering when creating an account, I used a package called short_id to generate some shorter unique IDs that are a lot more readable and a lot more useful for the teacher to type up on the board. So that's nice. One more thing to also mention the Firebase SDK in the backend, where we instantiate the Firebase app, and this is then used. It uses the JSON object for this particular Firebase project to get the rights of to be able to do different things in the application. For example, one thing it did, as mentioned earlier, it verified the ID token of the user wanting to make a request to routes who have the middleware. For example, listing all the users. But it also, when you're creating a user, over here, if someone wants to post a user, it enters the user controller, and the user controller then uses the Firebase SDK to create a user with the supplied email address and the supplied password. And if it's successful with creating a user, it then uses this. It then takes the credential to have the user ID assigned to the creation of the account. It then adds this specific user to the database. But one thing to note here is if the user is not able to be added to the database, it can then delete the user from Firebase once again. So they will not be able to have any hiccups with a user being added to Firebase but not the database or anything like that. Another thing to mention is similarly, if you want to delete a user, we also use the Firebase SDK to delete a user of the specified user ID. And then another interesting thing is that I made so you can, when you want to fetch a single user, you can send either the user ID from the mongoDB ID, and it will then fetch it from the database. But if that's not present, it will then filter it on the user ID from Firebase and send that user instead. So you can fetch a user with either the mongoDB ID or the Firebase ID, which was a really nice solution when I wanted to fetch a user upon login. Since I didn't know, since I have different IDs for mongoDB and the Firebase, it was nice to have this implementation so I could easily fetch the user on login without having to think in any way particular. So when you log in, the set user is called, and it then uses get user without user.uid. So you don't always have to fetch it with the Firebase ID. You can fetch it with either. Another interesting thing that I've used, since the mongoDB observable is not as useful as the one provided by Firebase, I've sort of cheated in a way that I've used the observables used from Firebase to have to update my own when the user is logged in or logged out. So if we go to Firebase, well, let's say a user logs in. So the Firebase auth login method is called. So it logs in with email and password, nothing particularly specific about that. But then Firebase themselves provide observable of the current logged in called auth user, which is out state from their current from their own package sort of. So this is an observable that is very finely implemented, and I'm then using that as my own sort of to update my own observables. So if you go to user, the shared user service, we then talked about the set user program. Set user, instead of having its own fetch method and having its own observable, which can then have errors if the user is not logged in, for example, I then use a switch map on the auth user's observable, which then is a way for me to utilize the correctly implemented observable, well, a lot better implemented observable than I will be able to do my own, and then I switch map that observable to return my own observable, which is get user for the particular ID provided by the auth user observable. So this is some sort of way to get around having a user set without having a user logged in, and if a user logs out, it also will be set to null, since the switch map is updated in that sense. And this is a technique I used quite often to have some sort of chain of dependency, where if the user logged in is a teacher, I want that teacher to also be stored as an observable. So here I have the user observable being sort of instantiated through the outstate observable. In a similar fashion, if we see a teacher in their shared service, I have used the setTeacher program function, method, whatever, and it then uses a switch map on the user observable. And in a similar sense, if there is a user logged in and this user is a teacher, it then fetches its own observable from the database. And this also gets updated when the user logs in and logs out in a similar fashion. And if we just continue down the chain, if the teacher is logged in, the teacher wants to be able to keep track of its classes. So in similar fashion, I have set classes, which switch maps on the teacher observable, and the chain like sort of dives deeper, or well. Another thing I had some issues with was for the students. If I'm logged in with a student, let's log in with Sara Johnson again. I wanted to be able to see what problems she had completed. So then I used the completed problems model in problems. And the completed problems model all it keeps track of is student ID with problem ID. And all I have to do then is filter out all the completed problem entities with the ID of this particular student, and then I filter out the problems that have the ID present in that list. So that was a nice solution to solve this issue, because in this way I don't have to store which problems are completed by a particular student on the particular student's own entity or model. I can then have my own like separate list, which is then on Firebase. Even though the students are on mongoDB, I can easily change sort of who has finished what. So if we see here, Sarah, she has completed all the problems. If I then delete all the completed problems entities and go back, we can see that Sarah has not completed any problems since she is not present in the completed problems collection. One more thing I've had to do a lot, I've had some issues with, is the continuous integration portion of the application. So I've implemented, so if you push the application to master branch, it will then be deployed, the front-end portion at the very least will be deployed to the Firebase hosting. So this I use Travis for, where Travis listens to the master branch and it then will do some commands, npm install of the different required packages, and it will then use build and deploy this to Firebase with a provided token present only at, this token is only present at Travis. So no one can access this token outside of Travis. But this worked very nicely since Firebase deploy is such Firebase hosting is so easily used. But then this is how I deploy the front end. But looking over at the back end, I deployed it on the app engine as mentioned. So I use app.yaml configuration file, and then I wanted to use Docker to deploy this application. So since then I have full power of how I want it to be deployed. So I have the runtime custom, environment flexible, and then some interesting, not so interesting settings, but this is some sort of minimal required settings to get the app engine up and going. So when I write gcloud or deploy it to Google Cloud, it then uses this file, and it then realizes, oh, I want to use this deployment uses Docker, and if we check the Docker file, which is not as easily readable, but it then imports, defines which image to build from, and this image then has the required packages to start off this API. For example, then Node, of course, but also npm to install the required packages. For example, the short ID, etc. So it first runs install Node to get the correct version of Node, copies the source code, but then it installs the entire application, and then it just runs npm start like I would when I'm offline to just get this to get the API up and running. And with the finely tuned server.js file, there were no issues when I finally got this up and going in a way that I was satisfied with, and when I finally got the deployment to work with this Docker file, there were no issues to actually to get this up live, even though it's not so secure, except for these token authorization checking.